Hello everyone, welcome to this podcast with Ronit Datta, one of my students from IIT Kharagpur. He studied physics, bachelor's and master's at IIT Kharagpur. Uh, Ronit,
Yes, sir.
in which year were you my student?
Sir, 2020, 2018 to 2020.
That's right. And what exactly you studied at IIT Kharagpur? You tell us.
I was in the Integrated Masters of Science program in the Department of Physics at IIT KGP.
So you are a budding physicist for me.
Yes, sir.
I have lots of questions for you.
Sure, sir.
To begin with, Ronit, we would like to know from you what were your challenges when you were preparing for JEE in your years of 11th and 12th regarding managing school curriculum with your JEE ambition. This mix of the things, did it in any way somewhere between the time period make an imbalance or create an imbalance such that you you felt like this was impossible, this could not happen, I cannot do it? What was the situation? What was the you can say entire set of things looking like?
So this dichotomy of school and JEE coaching often seems very daunting, and to be very honest, it is daunting given that it's one of the most difficult exams of in on earth. So the thing is, parents and our well wishers often think that these two are independent sets, and they often should be treated differently. In my experience, in my humble experience, and in I mean whatever I thought and came true, of course, was that these things are not really that different. The only things that might be different are certain topics, 1-2 chapters at max, that you might need to study extra for each of these purposes. For example, maybe there might be some chapters like biomolecules, for example, in chemistry or physics or maths, certain chapters that might not be applicable in like one or the other. But other than that, the very approach of studying for these two exams is I think very wrong foundationally, because things are pretty much the same. So, and given that JEE coaching is often more difficult,
That means here I would like to just summarize what you said so far.
yeah,
That the set of things that you need to study,
yeah,
the syllabus,
yes, pretty much the same.
is the same
Yes, it is pretty much the
for
same.
your board preparation.
Yes,
And you are from CBSE board.
I am from CBSE board.
And for JEE syllabus,
Yeah.
it's all the same.
Yes.
So, what is it different for JEE, or what is it extra for JEE that you need to do?
So personally, I went to Delhi Public School, Ruby Park, and that is a CBSE board school affiliated with the Central Board of Secondary Education, and it follows a very standard order of the chapters. And luckily, since it is also national board, and again IIT exams is also a national exam, both of their syllabus mostly overlap, and the overlap is almost more than 90%. And studying for any one of them without lying to yourself that you are studying, you are dedicating on one particular thing and sacrificing the other, is something that a lot of people make mistakes on. And I believe from my experience that that is a kind of a misconception that is often prevalent among students as well as their teachers. And since, as we know, JEE preparation, I'd say 50% of it belongs to skill, and the remaining of it is your wits on the day of the exam, the D day, let's say, and how cool you can keep yourself during the very daunting 6 hours of those exams.
Out of the three subjects
Yes.
in JEE,
Yes.
which one was your favorite?
My favorite, I mean, the thing was, at an age of, in 11th and 12th, the things that we study are incredibly foundational, and I won't say that they don't help, they definitely help, but the worldview of those subjects change. So, like, considering the fact that any of those three subjects might be your favorite is less important than thinking about it in terms of which one would be the easiest to crack and which one would be easiest in terms. For me,
should I say that means you did not really have any particular favorite subject?
I did have particular favorite subject, but again, that does not really play out on the day of the exam, because on the day of the exam, the one mindset that you need to carry with yourself is to score highest, optimize the examination.
Now, see, this is a very valuable viewpoint. This student is telling me that it does not matter which subject is your favorite.
Like the obvious bias that you have on
This is a
subject.
value I learned from Ronit. Thanks, Ronit. Okay, okay. Now you tell me which was your which was your
Strongest.
strongest subject. I mean your best one.
So the one that the focus must be unbiased and to all of these three subjects, and the concept of a favorite subject is correct, and I won't say it's wrong, but the problem is sometimes students think that skipping one over the other might be useful, but the thing is that does not play out during the exam, and I'll say why. There can be questions concentrated from a particular subject that might be subjectively easy which you skipped, and
Okay.
you lose valuable points during the exams on that particular subject that you probably thought was not that important. My strongest suit during preparation was chemistry, but I enjoyed physics more.
Okay.
Yeah, I enjoyed physics more, and maths is important. Maths is conceptual, but maths sometimes tests your wits, because on the day of the exam, uh, maths is less facts and maths is pen and paper, means you know some things and you have to apply it on the day. It's less of a rote memorization and more of a application based. And if there's, like for example, there are, I'll say one thing, like for example, let's consider coordinate geometry. For example,
Yes.
there are hundreds of different formulas for coordinate geometry.
Yeah.
Now for example, if you're tackling a problem on ellipsis or hyperbole, there can be three different equations for tangents, for example. You are thinking in terms of the things that you've learned, but often the correct approach might be the easiest approach, and that is something that students often miss out on. They might be thinking in terms of parametrics or other things. Maybe the simplest equation is the m1 m2 equals to minus 1 kind of a thing, and that is very important, because and that's something that you learn by watching videos of or practicing past year question papers, and that's a value that I've learned. Again, I have learned the hard way. And a message, let's say, to the viewers, I'd say, is to not think of them as daunting and take them as a matter of fact thing, because these are the way that things are. It's not something that is unintuitive, because it is literally derived from nothing. We consider a bunch of assumptions, and then those assumptions are not coming out of the blue, they are very much on paper. So the thing is, you have to tackle them objectively without having any bias in your head. Like this, like for example, it's a very popular trope, let's say, that chemistry has a lot of exceptions. Now if you have reservations about that fact, then you would in your mind unwantedly have reservations about that subject. But maybe if you consider that, obviously these are the system, if this is a system, then, like for example, static hindrance, or for example p like df elements, for example, have a bunch of exceptions. If you deeply do think about it, maybe if you do think about it, it would make sense. So the thing is, any bias is not good. The approach should be unbiased, and the approach should be the shortest, the quickest, again, because JE is not just a test of your intelligence, it's also a test of how fast your hand and mind will coordinate. So that's my advice in terms of JE.
Absolutely, Ronit. Now, Ronit, I would like to tell our future students or current students who are aspiring for JE
Sure, yes.
that, as you told us,
Yes.
Carrying any bias towards any particular topic or subject is not really needed. Am I correct?
It can be there, because
It
the
can be
the
there.
each the bias, the apparent bias that you have on a particular subject would help you figure or carve your way out in the future of what you want to study.
But
And
in
that is
JEE
important. But in JE does not, I mean, I'd like to say that it does not really care what your favorite subject is. What matters is whether you scored a good enough result or a grade, so that you
for
can
that,
yeah.
that means the subject preparation should be exhaustive,
Yes,
comprehensive,
comprehensive,
100%,
100%,
and without leaving out any section or topic.
preferably.
Am I making correction?
Yes.
This is what is needed.
Yes.
Okay, so that's a big point so far we have made. Now, going ahead,
Yes.
was IIT Kharagpur physics department was your only choice or you had options?
I had options.
What options?
Yes, I had
What
more
options?
options. So the options that I was faced with,
Please tell our viewers.
yes, so
What are the options you had?
I had IIT KGB Physics, I had IIT KGB Chemistry, I had IIT Kanpur Chemistry, and I had IIT Kanpur Economics.
Okay.
So, and again, each of these things can be gamified. Like if you attempt them, like what is the most optimized way, so that my approach might be different from yours. Because again, after the school and JE dichotomy, the second thing that comes into your mind once you've cleared the examination is college versus department, which means maybe I will land in top 5 IIT, but I'll compromise on the department, let's say, because of the fame of the IIT. But on the same hand, someone would say, I am not going to compromise on what I'm going to study, but at the same time, I can maybe go for a lower branch IIT, let's say, like IIT Patna.
Yes.
Now, is the gap between these IITs a gargantuan gap? I would say no. But the level and the standards that the top 5, not even top 5, let's say top 7 IITs uphold is obviously uh, different from the ones that are beneath. So let's say in IIT Palakkad, the expectations and the standards that you'd hold up to might be different from the standards that you'd hold up, or like hold your professors or students or faculty accountable for in these two scenarios. So there's a very intelligent student that I had, like friend that I had, let's say colleague, and he went to IIT Patna CS over IIT Delhi Textile Engineering, and that,
Well, let me bring you back to your choices.
yes,
So you had the choices of chemistry in Kharagpur, physics in Kharagpur, economics at Kanpur,
and chemistry.
as I remember, and chemistry at Kanpur.
Yes.
So why you chose physics?
So my idea was, the mindset of a huge chunk of students might be, we land any department in a top 5 IIT, and then when the department change issue, like the situation comes, we'll climb our way to the top by getting a
Did you try that?
nah.
You did
The
not.
thing
You
is,
stuck to physics.
I stuck to physics.
My physicist of the day,
I stuck to physics.
and maybe of the next decade. Yeah.
Thank you, sir.
Yeah.
So I didn't, because the choice that you make, you might think that it's a very volatile or temporary choice. The issue with that process of thinking is, things might not work the way that you want them to.
Well, that's great. Here I would like to ask a question, and very precise one.
Yes.
In the graduation studies or post graduation studies of physics,
Yes.
did you target any particular field of physics?
Obviously, you have.
What was that?
I have to, I mean, so the thing is, the field that I targeted, which is my field, was quantum simulation using quantum computing. The simulation is for chemical, nuclear, or condensed matter system. So condensed matter system can be anything ranging from superconductors, magnetics, or other spin systems, for example. These are condensed matter. My thesis project was on Ising model, and the work that I have done is also on dynamic reactions, QMMM reactions, and other things. And also I have done a separate study on quantum chromodynamics, which was in particle physics using quantum computing circuits. So given my experiences, if I don't craft for this might not be applicable, I mean, at this point for JE students, but when I applied for my PhD program, if you're not very precise and you're like, I will apply to a general department of physics, that will not work in your favor, because you need to be precise about what you need to work on. Now, the apparent precision might not be as much tunnel vision as you might think it is, because in that particular field of research as well, there are several sub niches of those research in which particular professors, research groups are working on. But you need to have a sort of ad hoc idea about one particular relatively big enough field of research that you want to work on. Like I said, quantum simulation for condensed matter, nuclear, and chemical systems. Now, the way to realize those kinds of simulation, you can use HPC methods, you can use tensor network methods, you can use simple advanced algorithms in using quantum circuits to realize the energy spectra of those systems, the ground state energy of the system. The most daunting questions in these times is to find energy spectra elements, first excited state, second excited state, using famous theories like DFT, Hartree-Fock theories, etc. So that's my field of research. So the getting back to the original question is the specification of the particular research area that you want to work on should be cleared or not. It should be very clear and should be specified and should be supplemented by the experiences that you have done. And does that mean that you have to be laser focused since first year to work on a particular field? Not really. And why? Because you might try a little bit of astronomy, you might try a little bit of gravitational physics, you might try a little bit of stellar physics, you might try a little bit of lasers.
It's always better to
It's
have
better to
a
explore.
exposure.
It's better to explore, it's better to try out everything and see what matches your taste. And once, and as quick as it comes, it is better for you. And once you find your taste, once you find your, let's say, calling, you must stick to it. And that sticking
So
thing,
should I consider you biased towards the relativity ideas? I mean, you are a relativist,
yes,
or should I consider you as a quantum theory person?
quantum theory person. Why?
You are a quantum theory person.
Yes, sir. Yes, sir. Because on a grand scheme of things.
So on this, I have a query.
Yes, sir. Sure, sir.
Does quantum theory
Yes.
in any way say
Yes.
that a photon has more than 2 degrees of freedom?
The photon and many other particles, like say polaritons, or the most common particle that we come across even in JE stage is the hole, the electron hole thing. Now, in reality, a hole does not exist. A hole is a gap, but it does travel. We can calculate dynamics of that. So what is a hole then? It's a quasi-particle. So degrees of freedoms of quasi-particles is something that one might not think so much about right now. Things that do exist, for example, like fermionic or bosonic particles, like quarks, electrons, or other particles that can be solutions of higher order or modified Schrodinger equations, we can think about degrees of freedom. And degrees of freedom, by the way, are not constrained to just motional degrees of freedom. There can be vibrational degrees of freedom, there can be magnetic states. For example, there can be like, for example, the very famous experiment, the Stern-Gerlach experiment, or Zeeman effect, etc. So the degrees of freedom, which a physicist might learn in a course, a thorough course in statistical physics, is a very general term. And if you want to describe any particular particle, you have to consider n number of degrees of freedom, and any dynamics acting on that particular particle comes as a matrix or an operator with those n into n times degrees of freedom. So the degrees of freedom of any particle can be considered, but it is best not to dwell on how they would materialize as. Like, does the electron rotate? Does the electron do something? I mean, it can do a lot of things. But in a literal sense, an electron is basically a charged cloud. Again, this might come as a shock, but again, an electron does not exist either.
You are not telling me a fact that electron can be considered as a cloud.
Yeah.
Okay, that's a new view.
Yes.
And then it's an accumulation of what?
Charge.
It's an accumulation of charge. Now, is that a fundamental particle then?
It is a fundamental particle, and the fundamental.
Means, you cannot break the electron any further?
No, because electron is a fermion.
Okay.
Electron is a fermion, and a fermion has odd. A fermion follows a bunch of rules. Now, how do you specify the statistics?
That's a great detail now.
Yeah.
I would like to again ask you the same question. Does photon have any degrees of freedom at all?
I wouldn't be able to answer that, but what I know is photon follows a particular statistical distribution. Natural light, and light again is a very, very, very interesting phenomenon, because you can squeeze light, you can do a lot of things with light. Okay. Light in general follows Poissonian statistics, but it can be changed, controlled, morphed into different kinds of things for our suitable requirements.
That's right. Now I have a broader question for you.
Actually, sir, can I elaborate on why quantum?
Yeah.
Why am I so focused on quantum
I'm
theory?
more than willing to listen to this.
Yes, sir.
Why you chose quantum as your field?
Yeah. So in the grand scheme of things like stellar dynamics or other things, the light coming from these far away galaxies is most of that physics is accurate, but it's very speculative. Like we cannot pinpoint on a bunch of things that come from things. We can propose theories like string theory, supersymmetries, different theories that come out as a natural occurrence of quantum field theory studies. The thing is that the kind of studies that I do is very measurable and real. Like, you might argue that you can't see it either, but I can control it, I can morph it, I can do what I want with it, use it. Like, for example, high speed internet today follows fiber optics. So fiber optics is also a very interesting phenomenon, because like a lot of electromagnetic radiation, it also attenuates, it can also be controlled, and it also follows the same Snell's laws that we know of. Again, we are entering mechanics from quantum theory. So this is the most interesting fact, that the kinds of things that I am dealing with, like for example laser technologies, or bits or chips, for example, these can be engineered. Astronomy requires engineering than itself being a field of engineering. And because engineering does not play around, engineering is a very solid field. It's there, and you can say that with certainty. Quantum, on the other hand, is also, because you can control it, you can say it with certainty.
Yeah.
But on a grand scheme of things, like Mars, like Ganymede can have ice. I mean, that's great, but what exactly am I supposed to do with it, right? Uh, so
Oh, okay.
Yeah.
I got your point.
Yes.
Almost. I would say almost.
Yeah.
Not entirely though.
Yeah.
Here, there is a forthcoming question
Yes.
on your going ahead.
Sure.
When you now have completed your masters
Yes,
from
integrated.
IIT Kharagpur,
Yes.
from the physics department. Going ahead, what would you like to do, or what are you planning to do, and which are the fields that you are focusing on?
So the fields that I am focusing on right now is, again, like the field that I have been working on so far. The realizations of the field, the algorithms that I develop might be different from what I have already done, but the offers that I have received right now, I have received 4 PhD offers. So, and I'll be choosing.
4 PhD offers. Point to be noted, my dear friends.
So
Yes.
and
From where?
One from Singapore,
Yes.
Singapore University of Technology and Design. Two from the United States, one from University of Michigan Ann Arbor, and one from University of North Dakota. And the fourth one is from University of Manchester, which is in United Kingdom. So for several reasons, I will be choosing Singapore, because it's a stable enough city, it's a metropolis, and it offers a lot of perspectives and broader aspects in studies, science, and technology, not just in quantum computing, but also in AI and robotics.
Now, we are listening to a physicist who would be discovering, certainly discovering new things in the coming decade. I would like to ask you, Ronit, here about the infrastructure, laboratory infrastructure. Which fields of physics that you are venturing into are you having a dream of working in? I mean, which types? So, like image sensing, low light imaging, or maybe astronomy, or maybe it can be like gravitational. Which types of labs you are having a fascination to work in? I mean, day in and day out, you would like to work in that. Which are those fields?
So, since I mentioned I am working on quantum computing in realistic
He's a
sense,
man of quantum.
yeah. So, so in a realistic sense, requires qubits to function. These qubits can be realized in several different ways, and a qubit, in simple sense, is a two-level system of a 0 qubit and a 1 qubit, which can present itself as a combination or a superposition, as well as there's a very interesting property which is known as entanglement, which it can do for multi-particles, multi-qubit systems.
You are going to work on entanglement?
Entanglement is a natural phenomenon of multi-qubit systems, and entanglement is a theoretical aspect. In order to realize it experimentally, there are several architectures for qubits some of which can be superconducting qubits, some of them can be trapped ion qubits, some of them can be neutral ion qubits, some of them can be silicon qubits, one is photonic qubits. So there are several realizations of qubit technologies, and there are several companies that work on these qubit technologies. Xanadu works in photonics, IonQ works on trapped ions, uh, QEDA works in
So,
neutral
so
atom.
you are like you are having now a fascination to work in this field.
This field, and the laboratories that cater to these fields are the ones that work in similar fields, like for example labs that have laser technologies, laser cutting facilities, labs that have qubit chip making capabilities.
That's great. Now, before we run short of time,
Sure.
one last question.
Sure, sir.
Is there in any way you are going to work on superconductors?
Yes, because the university that I'm going to, they have an incredible infrastructure to work on superconducting qubits as well as fabricating those superconducting qubits. And the way they are done is using a fascinating phenomenon called Josephson junction. And I have seen their lab working on them. There's a scientist called Yuan Gao in the Center of Quantum Technologies in the National University of Singapore in Singapore, and they work on very interesting. There's another professor called Manush Mukherjee who is also involved in these kinds of studies, and the labs sometimes can be working on laser technologies or trapped ions, like trapping an ion in a particular bath that basically restricts the dynamics and the motion of that ion, and we can do a lot of things like simulation, like trap, like other, like prove the dynamics of that ion. So the labs that I would be working on usually deal with these kinds of things, and they are self capable and they have the funding to provide machinery to realize those particular experiments to the best of their, to the state of the art facilities available in the labs that I will be working on. And I look forward to see like like, so I am a theoretician, but a theory does not really make a lot of physical sense until and unless you see them being realized in a realistic fashion. And to see that happen, you need to visit labs that work on experimentation, and that is a facility that is available. And that was also an important aspect of my decision in going to Singapore, because they can afford those machinery and those experiments in their labs.
Okay, see that. Uh, I will wish you all the best in your future endeavors and your future studies.
Thank you, sir.
Thank you so much, Ronit.
Yes, sir.
And thank you, viewers, for showing patience. Stay subscribed.